Hey there, BCSD third graders. This is Mrs. Whitman from Poly Elementary School, and I'm coming at you today with an explanation for the Day 2 math task for the second distance learning packet that was passed out during spring vacation. All right, let's get to it. It says, Jose, Sam, Nikki, and Zach each have 7 markers. How many markers do they have altogether? Okay. So I'm going to note the important things first. I noticed that there are, there's one, let me switch to my pen function. There's 1, 2, 3, 4 people in this math problem. Okay, that's going to be important in just a second. Each of those people, a very important word in math, have 7 markers. Okay. So this is kind of sounding like a multiplication problem to me because I note the word each. I know that each person has the same number of markers, and it's asking me how many markers do they have all together. So I'm expecting the number to be a big number once I add all of this together. So whether I want to approach this with repeated addition, with an array, with equal groups, whatever multiplication strategy that I have in my back pocket, that's what I can use. So I'm going to use equal groups just because it's a highly visual way to solve this. And I'm gonna do some fun labeling with it. I'm going to make a group, and I'm going to make one for each person in this math problem. I'm going to make one for Jose, one for Sam, one for Nikki, and one for Zach. Okay, each of these circles stands for one of those people. And I'm going to then put my tally marks inside of my groups to show that each of them have 7 markers. So I'm going to count to 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so far so good. How many markers do they have altogether? Now, I could go ahead and just count all my tally marks up, but that would be pretty tedious. That means it would take a long time. I could go ahead and write 7 plus 7 up here. I know there's 7 in each of these. I know that's 14, okay? And that means that this is also 7 plus 7 equals 14. And then I could add my 14s together, okay? So I'll do that down here. 14 plus 14 equals 28. Okay, so we have arrived at the final answer, but I'm going to show you one other kind of tricky way that you could count the numbers. This is why I like using tally marks inside of the groups, because what I can do is I can count the 5s that I see first. I'll use red so I can show you what I mean. Okay, there's a 5, 10, 15, 20. Okay, I've got 20 just with my 5s that are inside of the circles there. Then I'll use another color for my leftovers. Let's use blue. So I've got 20, and then I've got 2, 4, 6, 8. I just counted by 2s for the remaining tally marks. So all I've got to do is add 20 plus 8 now, and I get the final answer. So 2 different ways of arriving at the final answer, but it does not matter how you count it up as long as you get the job done. All right, we're going to move on. I do want to show you something on the reteach page. The reteach page may look a little bit confusing, and what I wanted to touch on is they're trying to get you to use a new math strategy called decomposing. You may or may not be familiar with this multiplication strategy, decomposing. decomposing. Cannot spell and talk at the same time, okay? This is just another multiplication strategy to have in your toolbox. And it's really useful for when you start multiplying with large factor numbers, large multiplication facts like 7 times 8, 6 times 8, 9 times 9. If you don't have those bigger multiplication facts memorized yet, then decomposing can be your best friend. I promise you. And I'm going to show you 2 examples to show you how easy it is, okay? So let's look at number 1. I'm not even going to pay attention to the example because this is easier down here. Okay, number 1. Now, ordinarily, we would say, okay, yeah, this is going to be great. It looks like an array. An array is something that I'm familiar with. I'll go ahead and start counting my rows and columns. So I see 1, 2, 3, 4, 5, 6, 7. There's 7 rows. I should have labeled them. There we go. Okay, 7 rows, and I'm going to go across this way to count my columns. There's 1, 2, 3, 4 columns. So that means I know I have to do 7 times 4 in order to arrive at my answer. Now, but what if I don't know 7 times 4 yet? What if I haven't memorized that math fact and it doesn't come that easily to me? Well, there's another approach that we can use, and that's called decomposing. So I'm going to just erase this real quick. I'm going to start over again. Okay, with decomposing, what we do is we take the array and we chunk it. We break it up. So I'm going to break this array up. I'm just going to draw a line right in half. Okay? I'm just breaking it in half. And now what I've done is I've taken one big array and essentially chopped that array in half to make 2 smaller arrays. Okay, so now what I'm going to do is I'm going to count, and I'm going to use a different color for the top array and for the bottom array. Okay, let's start with this one. I see 1, 2, 3 hearts. Okay, 3 rows of hearts above the line I just made, and then 1, 2, 3, 4 columns. Okay. So for this part right here that I'm circling in green, the math fact is going to be 3 times 4, okay? And most of you, from doing so much math in 3rd grade, you already know that 3 times 4 equals 12 because you've memorized that one. Now let's use a different color for finding the bottom one. Okay, we've got 1, 2, 3, 4 rows this time. Okay, on the bottom, and we've got 1, 2, 3, 4 columns. So for this part of the array circled in blue, this time I'm going to do 4 times 4. And most of you probably know that that equals 16. So now, to get my final answer, all I have to do is add these 2 bad boys together. Okay? I'm going to add 12 and 16. So I'll do that off to the side. 12 plus 16. Okay, I'm going to do my ones column first. That's an 8 and a 2. Okay, and that gives me 7 times 4 equals 28. All right? So I know that was a little bit fast, so I'm going to do it one more time with you on number 2, and then I'm going to let you loose so that you can practice on your own. Okay, let me erase what I just did to give myself a little bit more room. Okay, here we go. So I think I'm going to chop it up. We'll just try to chop it right here. There we go. I've got my 2 smaller arrays now because I just broke it apart using the decomposing method. And now I'm going to start counting my rows and columns in the smaller arrays that I just made. Okay, so I've got 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, so that's going to give me a math fact of 3 times 6, and that equals 18. Okay, now I'm going to use a different color to do the bottom part. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, this time it's going to be 4 times 6. And that one equals 24. So now all I have to do, again, is just add them both together. I'll do that off to the side. 18 plus 24. 8 plus 4 is 12. I'm going to regroup. And then I've got 2, and 2 is 42. All right. So now you can take a look at that part of the video to get some more practice with decomposing. Try number 3. And then you might want to get a piece of scratch paper so that you can use decomposing to practice these ones at the bottom, because they don't give you very much space, and it's very helpful to draw an array. You're gonna want to draw an array to help you break down these really large math facts. Okay, particularly I would say for 7 times 7. Try the decomposing trick. Okay, this one, 7 times 9, 7 times 6, and 8 times 7. Those are the ones that decomposing will probably be the most helpful for. Alrighty, boys and girls, I will be back with another video for day 3 in a little while.